Okay, my voice is coming now. Am I audible now? Am I audible? My voice is audible now. Okay. Voice is coming or not? Just quickly say. My voice is audible or not? Kanishka, school test, only your polynomial test is there na in school. Audible na? Polynomial school is there. In school also you have polynomial test. School also you have polynomial test na beta. In school also you have polynomial test. So only I am conducting a polynomial test for your overall revision. Fine. So that in whatever school part they are going to ask, I am going to do the same thing. So you have to cooperate, because final exam I am not teaching like that. This is not my way of teaching. Conduction of test means conduction of test. Offline test means offline test. Due to COVID only there is a delay of 5 days. I am very strict about my rules. So writing test today means writing test today, and whatever content I have told you, you have to exactly follow that. Write the test in page, you have to submit. So since COVID is there, in I am not allowing you to or your parent to come to me and submit the answer sheets. So only one thing is there, that you can keep the answer sheet, give it to your parent, and Saturday when you are coming, you have to bring that. For writing test you have to bring. Okay. Don't worry, your polynomial test will be easy. Your polynomial test will be easy, it will not be tough. Your polynomial test will not be tough, it will be easy only. Only NCERT questions I am going to give. But that test is very, very important. Fine. Because revision I have to start. I cannot stop. I cannot stop. Okay, so only I can reduce the content, I can reduce the toughness of the question, but I cannot cancel. So whatever you have studied till now, based on that only I am going to conduct test. Don't worry about it, don't get scared about it. Okay, it will be just easy test. Fine. So send the link in the group. Many a times we have discussed about polynomial. What is my duty? I am doing it. If I will not do this duty, then it will be wrong. So I am doing my duty right now. Okay, because your confidence exam is coming. So chapter wise revision is my duty. So now look here. Now we are going to go towards power. First I have to finish my syllabus. Otherwise it will be again a problem. Now look here. What is power? Now what is power? This chapter is going to be finished. Now I am going to explain power. So if somebody will be telling you, you know that I am a very powerful person, how to judge the power of content, how to judge the power of something, how to judge the power of something. If I am telling you, okay, fine. So now just understand what is exactly called as power. So if somebody will be telling you that this is power means this bulb is having this much power, this appliance is having this much power, this tube light is having this much power, this TV refrigerator is having this much power. So what does that power means there? That means how much that appliance or bulb or TV is capable of doing work by dragging some amount of current. That is exactly the power of that appliance, more or less. So if you and your friend are standing there, standing in a place, and I told you that can you show me your power? I told Vishal that, Vishal, can you lift 5 kg weight? And then I said what you call Keshav, that Keshav, can you lift 10 kg weight? So I have exactly given 2 different weight to 2 different people, and exactly if Keshav I have given what you call 10 kg and Vishal I have given 5 kg, and then I told them, can you lift it? And both of them have lifted. Then I just interchange and I allowed them to lift it. Again they lifted. That means they both are capable of holding 5 kg and 10 kg, means they have that power capacity to do that work. Okay, but then I replaced that with a 15 kg weight. Then they both were unable. That means their power is to take on till 10 kg. Their power is to take on till 10 kg that power is to take on till 10 kg. More than 10 kg they were unable to do that work. So that means we learned a very important thing, that power is capacity to do work. Okay, so means if I am having a power, means if I am having power, I will be capable of doing a work. If I am having power, that means I am capable of doing work. So what is exactly power? The rate of doing work is called as power. What is power? The rate of doing work is called as power. What is power? The rate very good, Keshav. So up to 20 kg Keshav can lift it. So 100% we came to know one thing, that he is more powerful, okay, than Vishal. So Vishal cannot be able to lift 20 kg, but Keshav is able to lift 20 kgs. So since Keshav is able to lift 20 kgs, he is more powerful than Vishal. That why? Because he can do more work in compared to that of Vishal. So now Vishal, how much you are going to lift? You know, you have to type and send me. So one thing we have understood, that the capacity or the rate of doing work, the rate of doing work is exactly called as power. The rate of doing work is called as power. Okay, now power related questions are exactly going to come in your examination. So 15 kg super Vishal. So Vishal has told that he can lift 15 kg. So I have understood one very important point here, that capacity of doing work is different for both of you, and that is what. So each and every electrical appliances, if we are talking about each and every human being, now in physics we are not going to relate human being with power. We are going to talk about certain objects and its power and its rate of doing work. Okay, so basically when we judge the power, we judge the power of certain appliances or vehicle, or what you call the power. Like you will say that, hey, you know that a new bike has came, and you know that it's exactly very, very powerful bike. Then how we are judging the power of the bike? You will be saying, you know, the speed of the vehicle is this, and it can exactly run in this much petrol. So that means it is very, very powerful. Bullet bike is there. So you talk with your friends like that, isn't it? So you talk with your friends, so you are judging the power. So we have understood one thing. Sharmila, good evening, good morning, Sharmila. So here the most important thing is, we are judging the power by the capacity that appliance or that vehicle or that content is doing work. So the rate of doing work is called as power. Can you type and send me what is power? For you, what is power? The rate of doing work means how much you will do work per unit time is exactly power. How much work you can do per unit time is power. Okay, so if I can say you to lift a weight and just move from one place to another place, how much displacement you have done or how much work you have done in what unit time, in how much time, that will be showing your power. So the rate of doing work, okay Sharmila, the rate of doing work, start doing this beta. The rate of doing work is exactly called as power. Today's session numericals will be there, because in examination one single numerical. Now whatever test I am going to conduct, it will be mostly online, offline. So there I am going to judge your total capacity, how much you can be able to answer. Okay. So oral tests will be there for final preparation. So many things are there. I have already aligned everything. So this week you will come to know. But morning 6 to 7 you will be having class. Not 6 to 7, 6 to 6:45 sharp you will be having class. At that time you are going to study chemistry. So this full morning 6 to 6:45 you will be having chemistry classes. Evening also tomorrow I am going to keep chemistry class still, because math syllabus is over. Now physics, this today it is going to be over. So chemistry from tomorrow I am going to start. So now look here. So what is the formula for power? So now already we have seen that the formula for power is work done by time taken. I told you the rate of doing work is called as power. So power is work done by time taken. Simple way. Power is what? Work done by time taken. So now we are going to present power as P equal to W by T. W is what? Work done. T is time taken. So the rate of doing work is nothing but power. So now in other word, power work done formula is what? We have done from last many weeks, we have last I think 1-2 weeks we are doing work done, work done, work done. What is work done? Work done is force into displacement. What is work done? Absolutely correct, Rashmi. So what is work done? Work done is force into displacement. So what we are going to derive here? So we are going to remove this part. So we are going to check that given power is equal to work done by time and work done is equal to force into displacement. Now is it visible? Work done is equal to force into displacement. Now remove this work done by that. So power is equal to force into displacement by time. Now you know that displacement by time is nothing but velocity. So this whatever work we are doing all this for numerical purpose. I am just telling you right now only. So power is equal to work done by time. Work done is force into displacement. Formula for work done is force into displacement. Displacement by time is nothing but velocity. So we can say power is equal to force into velocity. Power is nothing but force into velocity. So I have derived one new formula for you, and that is power can also be equal to force into velocity. Power is force into velocity. What will be the unit there? Then here it will be Newton is the unit of force. Velocity is meter per second. So Newton meter per second, and it is exactly going to be what? It will be considering as Newton meter per second is what? You will be saying, auntie, Newton meter per second. Here you are talking about what only, auntie? So if I am going to change that also, work done is nothing but force into displacement. Work done is Joule. Joule per second is what? Joule per second is exactly, Joule per second is your what? Okay, so Joule per second also here it is coming if we are going to replace. So power unit is not changing. So here Newton meter per second also you can write, and what you can also write. So here one thing is there that, but we have derived another formula where we are exactly writing force into velocity. So force Newton, velocity meter per second. So when this power unit is what, and what is Joule per second? So you have to remember this one. You have to remember this contents, means force, that's what I have just related the SI units, because many a times when we are changing the physical quantities, force is a physical quantity, displacement is a physical quantity, power is a physical quantity. Okay, so now all these physical quantities, they have different SI units. So when we are changing the physical quantities, that time the units you have to precisely, specifically in numericals, the units you have to precisely change. So only I have discussed this, so that at the time of solving numericals you should not do mistake. Power SI unit is what? What is the SI unit of power is what? What is equal to Joule per second, because work done by time. What is the SI unit of work done? SI unit of work done is Joule. So power equal to 1 power, if we are going to say that 1 watt. 1 watt means SI unit of power is 1 watt. So 1 watt equal to 1 joule per second. 1 joule per second. 1 joule per second. I hope you might have understood this point. So 1 joule per second is the SI unit, and that is exactly equal to what? So now what is average power? Average power means like how much work you have done. Adding all the work together by how much time you have taken to do this work, that will be called as average power. Okay, so I gave 2-3 work to you and you have taken time to finish all that work. Okay, then I said that what is your average power? Then you said, auntie, you know, first work I have done and second work I have done, third work I have done. In all, then doing all that work I took this much time. So I told add all the work how much you have done in joules. So now you have added all the work by total time taken for doing that work. That will become the average power. I hope you might have understood. T, what is the unit of power? S. T, I have written something somewhere, beta. Work done by time is there, beta. SI unit velocity is there. Maybe some typing error is there. Where is that, beta? Show me, Rashmi, where is that? Total work done by total time taken. Total work done by total time taken. Here, T, S by T is displacement by time, and displacement by time is velocity I have written. So, power equal to force into velocity is there. No, I didn't got that. T, what is unit of power? S, what, sir? T correct. Oh, that was a joke. I said some typing error is there. Now, thank you, Rashmi. Now, look a bit. So, we have understood another important thing is the average means energy consumed by time taken. I told you another important point that when we relate power with electrical appliances, then that time the work done by the electrical appliance, how to come to know that what work that electrical appliance has been done. So if I am going to give you an electric toaster and if I am going to give AC content and I'll tell that okay, the electricity consumed by, if I'll say that they have done this much work done, you will be saying that auntie, how to know that this toaster and this AC has done any work? Then you will be telling that auntie, I don't know how to relate this one. Then I'll tell you that see who is consuming more electricity. Can you tell me the toaster will consume more electricity or T is the teacher? What is the unit of power, student? What, sir? Teacher, correct. Okay, now look here. So if somebody will be telling you that which one is exactly doing what work, then you will be saying that auntie, how can we relate this work? But if I will say that among AC and electric toaster, which one is consuming more electricity, then what answer you are going to give? Yes, Keshav has given the answer. Very good, Vishal has given the answer. We all know that AC electrical consumption is far more than electric toaster. So what we have understood here, that means we can understand which one is more powerful. So which appliance is more powerful? Then you will say that auntie, AC is more powerful. You know why? Because it is consuming more electricity. It is consuming more electricity. So by rate of consumption of electricity also we can find the power of electrical appliance. Come on, we can do like that also now. So if somebody will be asking you which electrical appliance can do what work, then you will say that auntie, it is very simple. The electrical appliance which will consume more energy is more powerful because it is exactly having the capacity to drag that amount of current, and if it is dragging that much amount of current, that means it is doing that work also now, because electrical and electricity consumed by an appliance will directly get converted into mechanical energy, means it will do some work. So it will not do one thing, it will not consume the energy and keep it with. No, AC is consuming energy and cooling the room. So exactly it is doing work. So what is the work of AC? AC is consuming electricity so that its compressor will be exactly, so that will exactly do the work and it will exactly cool the room. So 100% when it will be exactly doing the work, that time the work done is to cool the room. So 100% it has done work. And we can see the work of AC now. If it is cooling the room, means it is doing work. If it is not cooling the room, means it is not doing work. So we understood that if any electrical appliance power we have to rate, then we can understand it by how much amount of electricity it is consumed. Now don't relate it with like energy efficient appliances, this thing, that thing. We will study this in class 10th. So electrical appliance efficiency also we will be discussing. But right now for understanding, I have just explained this point that if I need to explain the power of electric toaster and AC, we will say that per unit time the electricity consumed by AC is more than that of electric toaster, and that means the power is exactly more for AC than for toaster. I hope you might have understood this simple point. So that means power is also called as electricity consumed by time taken. Electricity consumed by time taken. So what is power? Power is a vector quantity or scalar quantity. Then power is having magnitude, but it does not have any direction. It is not direction specific. So since it is not direction specific, we can say that power is a scalar quantity. We can say what? We can say that power is a scalar quantity. Okay, but no, it is having magnitude but does not have any direction. Since power is not having any direction, we can be showing that power is a scalar quantity. So we have understood a very important point: work, energy, power, all the three are scalar quantity. No confusion about it. Work, energy, power, all the three are scalar quantity, none of them are vector quantity. Fine. So now we are going to understand the SI unit of power. Then you will be saying that, auntie, it is very easy. SI unit of power is what, and 1 watt is joule per second, 1 joule per second, and that is what, and it is named in honor of the person who has exactly invented it. So it is exactly Shruti. What is the efficiency of work done? Efficiency of work done means कि with what efficiency, see, look at each and every electrical appliance is exactly having some efficiency. Efficiency means कि when we are there some stars are there, Shruti. So you will be seeing that कि when your father or mother went to buy any electrical appliance, now they will be putting 2 stars, 3 stars. Then you will be seeing that energy efficient. Energy efficient means कि in compared to other AC, if both the AC will work for 1 hour, your appliance will drag less current in compared to that of the other appliance, and that's why cost cutting will be there. So means your appliance will be more costly than the other person appliance. So they are exactly called as energy efficient. Energy efficient means कि it will not be taking that much current. Okay, it will not be taking that much current. That is a different thing. Okay, so that is related to appliance I just talked about. Okay, Shruti. So you will be seeing stars will be there specifically for electrical appliances. You will be seeing that they will be putting stars and they will be trying to entertain you, trying to do the business by saying that in 1 hour this will take less current, this thing, that thing. Many things are there. They are market strategies only. Okay. So now we are going to talk about the next one. So what is 1 watt? 1 watt is 1 joule per second. The rate of doing work is exactly what? The rate of doing work is power. So when work of 1 joule is done in 1 second, it is exactly called as 1 watt. So the 1 watt is the power of appliance which does work at a rate of 1 joule per second. So that is what is the definition of 1 watt. So this question may come for 2 mark. Define 1 watt. Define 1 watt is a very important question. Define 1 watt. So exactly what is the definition of 1 watt? 1 watt is the power of an appliance which does work at a rate of 1 joule, which does work at a rate of 1 joule, okay, per second. So now 1 watt is 1 joule per second. So power of machine is 1 watt if it does a work of 1 joule in 1 second. So now we are going to talk about unit of power. We have already discussed. Now we are going to talk about higher unit of power. So kilowatt hour is there, kilowatt is there, megawatt is there. So what is the difference between kilowatt and megawatt? So 1 kilowatt is equal to 1000 watt. And 1 megawatt is 10 to the power 6 watt. So 1 is 10 to the power 3 watt, 1 is 10 to the power 6 watt. That is the difference. That is the difference. So megawatt is a bigger unit in compared to that of kilowatt. Megawatt is a bigger unit in compared to that of kilowatt. So now exclusively, but you know what? कि when we sometimes we are exactly going to specifically for vehicle na, we want to understand the power of the vehicle. So that time we are talking about 1 watt will get converted into horsepower. So exactly called as 1 horsepower is equal to 746 watt. So for vehicle and all, the capacity or the power of the vehicle will be judged for horsepower. So it is exactly called as 1 horsepower is equal to 746 watt. Okay. So 1 horsepower will be exactly equal to how many watt? 1 horsepower is equal to 746 power. This unit still use the output of automobiles, motorbike, car and pumps. So this is what I told. The capacity of the vehicle means what is the power of the vehicle will be judged by this unit. So 1 horsepower is equal to 746 watt. So that is the capacity. Yes beta, it is called as horsepower. Electrical appliance, you see that what is there? Kilowatt is there, megawatt is there. So you might be seeing in electrical appliances this watt, kilowatt will be written, fine. But when we are talking about vehicles, that time we cannot say watt, that time it is coming as horsepower. So 1 horsepower is equal to 746 watt. 1 horsepower will be equal to 746 watt. So now in your house the electricity is measured in which unit? So one commercial unit is there. So each and every house is having a meter. In that meter one unit is written there. So what is the unit written in each and every what you call meter? That is kilowatt hour. So how much in your house electricity is consumed, that electricity unit is written as kilowatt hour. So what is the commercial unit? Commercial unit, the commercial unit is kilowatt hour. Commercial unit beta, because this is a bigger unit. What is a smaller unit? So horsepower, you have to understand one thing, this horsepower is a bigger unit. Okay, so like stroke engine is there in the vehicles and all. So this stroke engine capacity cannot be measured in unit. What is a smaller unit? So horsepower is a bigger unit. So 1 horsepower is equal to 746 watt. Okay, I hope you might have understood. So in commercial unit, so in every house you have a meter. You go there and you will be checking that the meter will be written as, the recording of the meter is written as kilowatt hour. So how much energy consumed, electricity consumed by your house will be coming in kilowatt per hour, kilowatt per hour. So if in your house that meter is written as 200 kilowatt hour, that means what? 200 kilowatt hour is the energy consumed by your house. So this is exactly will be written in the meter. Okay. Horse is more powerful than donkey. Okay, because horse is having more muscular energy. So each and every electrical appliances, each and every vehicle, the vehicle capacity can be judged with the one which is having more speed. Okay, so we are not calling it as cheetah power, because cheetah, horse, so horse is known for its efficiency, its running, and it can travel to longer distance. Okay, any animals, if you are going to relate, it will be not having that much capacity as horse is having. So only it is written as horsepower. Okay, so now look here. So now commercial unit of electrical, so kilowatt hour is the commercial unit. The SI unit of electrical energy, we know it is exactly going to be joule. So 1 joule is the amount of electrical energy consumed when an appliance is exactly going to do a work of, so it is having a power of 1 watt. Okay, per second it is exactly consuming. So kilowatt hour. So mostly what they will ask is, so mostly it is exactly, mostly when they will be asking this kilowatt hour. What is the commercial unit of power? So they are going to say that the commercial unit of power is kilowatt hour. So each and every what you call house, there is a meter, and in that the electricity consumed will be represented in a unit called as kilowatt hour. Okay, so power, each and every appliances will have a power to drag current and do work. So how much power it will have? It will come in watt, but bigger unit of watt is kilowatt. So kilowatt hour means per hour how much kilowatt of energy, electrical energy your house is consuming, means your house electrical appliances is consuming, that will be exactly coming as your electricity bill. So this bill means kilowatt hour will get converted. So like just understand that in 2 months your house, just understand this simple thing, like your meter recording in 2 months is 2000 kilowatt hour. Now 1 unit cost, 1 kilowatt hour cost. So every government is exactly keeping a cost. So they are telling that 1 kilowatt hour is exactly costing 5 rupees. Rupees 5. Then in 2 months you have exactly used this much of energy. Okay, so now 1 kilowatt hour cost is 5 rupees. Then what will be your electricity bill after 2 months? What will be your, now I am just telling it as 5 rupees. Okay, so now tell me what will be your bill after 2 months? Can anybody tell me? 10,000 rupees will be your bill. So how much energy, electrical energy in kilowatt hour your house will consume in 2 months by their electrical appliance, that will directly get multiplied with the unit cost. Okay, means 1 kilowatt hour cost the government will be fixing, and that will multiply with how much energy in the meter it is written, means how much energy consumption consumption or electricity consumption your house has done, house electrical appliance has done, and that will get multiplied directly. So it will come as the money. Okay, I hope you might have understood this point. Come on, quickly tell me. Understood this point, yes or no? Commercial unit understood? Commercial unit understood, everyone. So now we are going to go towards the last part of it. So 1 kilowatt hour is the amount of electrical energy consumed in electrical appliance, where 1000 watt is equal to 1 kilowatt. 1000 watt is equal to 1 kilowatt. Now we are going to create a relation where we are going to convert kilowatt hour into joule. So now I am going to derive this relation. So I am going to just do this relation now. I am going to derive it in this screen. So I am just waiting for it. I'll convert 1 kilowatt hour into joule. So if I want to convert kilowatt hour into joule, let's see how much it is exactly going to come. So joule per second we are going to convert. Leave it, we are going to do this one. Now another important thing is 1 kilowatt hour, another name is BTU, Board of Trade Unit, and this is exactly 1 unit electricity. Board of Trade Unit, why? Because I told you na, each and every government has exactly, the government has fixed an amount of money, so that is exactly that 1 kilowatt hour will directly get converted into money. So that's why it is exactly have another name called as BTU, Board of Trade Unit. What it is exactly called as? BTU, Board of Trade Unit. What word I am using right now? BTU. BTU means Board of Trade Unit. Board of Trade Unit. So other name, if somebody will be asking, then you are going to say that 1 kilowatt hour can directly be converting into money. So we are exactly calling it as by another name called as BTU, Board of Trade Unit. Board of Trade Unit. Absolutely, Ashutosh. Good morning. So Board of Trade Unit. So what it will be called as? Board of Trade Unit. Now we are going to convert kilowatt hour into joule. So kilowatt, Michael Jackson is also here. So MJ. So now look here, kilowatt hour. So first we are going to convert kilowatt into watt. So we know that 1 kilowatt equal to K will be small, W will be big. Okay. So 1 kilowatt, K I am going to write small so that there should be no confusion. So 1 kilowatt we know that equal to 1000 watt. Come on, we can write like that. So now 1000 watt written. And after writing 1000 watt, we have to write here hour. Hour can get converted as second and minute. So 1 hour equal to 60 minute into 60 second. So now we have watt into second. So now 6 into 6 will become 3, 6, 1, 2, 3, 4, 5. So 36, 1, 2, 3, 4, 5 zeros are there. It is coming as joule second. Okay, so here, sorry, watt second. Watt into second is coming. So now watt into second is nothing but joule. So now we can convert it as, in standard unit it will become 3.6 into 10 to the power 6 joule. So we converted watt into second is exactly joule. How watt into second is joule? Because power equal to work done by time. So if 1 watt we are writing, here it is work done, fine. So 1 watt if we are writing, then it is exactly written as 1 joule by 1 second. So watt into second will be equal to 1 joule. Come on, we can write like that. So watt into second I just replaced by joule. So 3.6 into 10 to the power 6 joule. So 1 kilowatt hour is nothing but 3.6 into 10 to the power 6 joule, and we know that 1 megajoule, that is what I was talking about, Michael Jackson I said. So you know that 1 megajoule equal to 10 to the power 6 joule. So replace this 10 to the power 6 joule as megajoule. So it will become 3.6 megajoule, and that is what I was saying about Michael Jackson. Okay, hi gamer. I hope you might have understood this point. It's just the simple one I just talking about. Yeah, I'm feeling much better. Thank you for yesterday, beta. God bless you, huh? Yesterday I was feeling like stupid, totally gone out. After I started class now, I was becoming so weak. I felt very weak yesterday. So now we understood the commercial unit of power, and then we have understood that SI unit of power, bigger unit of power, smaller unit of power. Let's start solving some questions. Okay, how are you, gamer? So now ready for numericals. So one question is, so one athlete is there, ATHLETE. I have added one extra E, ATHLETE. An athlete is exactly weighing 60 kg. Okay, the weight of the athlete is how much? 60 kg. Huh? And after that, the athlete is doing one work. It runs up a staircase having 10 steps. So it is runs up a staircase having 10 steps. 10 steps. Only 10 steps. Each of 0.5 meter in 30 seconds. Okay, calculate its power, calculate his power. So now we can calculate the power of the athlete. Calculate his power. You have to take G equal to 10 meter per second square. Okay, now talk about this, solve this question. Very tough question, you know. So what will be the total energy conserved in this method? So first work is, do you want to solve this question, or should I solve this question? Now look here, the most important thing here is that mass of the athlete is given. Mass is given, weight is not given. I am telling you, because it is written kg. If Newton might have been written there, then we could have talked about weight. So here we have written kg. So first thing is that what is the energy stored in that? So energy stored is exactly potential energy. Fine, and that potential energy here it is using. So now in this process, what we are going to write first, we are going to write potential energy equal to mgh. So mgh, mass into acceleration due to gravity into height. So to get the height, what you have to do? Come on, go for it. Go for this question. I have given you a link. Okay, so exactly 10 steps are there. So here how many steps are there? Only height finding is there. So total how many steps are there? Total 10 steps are there. Each step is 0.5. Okay, each step is 0.5 and he is exactly running 10 steps. So what is the total height? So total 10 steps are there. Each step is 0.5. So what will be height? So first we are going to talk about height. So height will be 0.5 into 10. So it is exactly going to come as how much? It is 0.5 into 10. So Keshav has given the answer 100 watt. Keshav has given the answer 100 watt. Okay, Keshav, let's check this one out, beta. So now first we are going to talk about potential energy, means work done. Here work done will be exactly how much energy will be stored inside him. That much energy he is exactly going to use for going up in the staircase. Come on, we can say that now. So here what we are going to find, that weight is exactly, mass is 60, that is coming as 10 into, this part is exactly going to come as how much? This is going to come as 5. So 6 5s are 30. So this much joule. So now power is equal to work done by time. Now work done here is the total potential energy stored in the athlete, and that work that is exactly used for doing the work. So here it is coming as 10,000 joule by time. So what is the time here? 30 seconds it is given. So we are going to kill this one. Answer is coming as 100 watt. Okay, absolutely correct. Answer is coming here as 100 watt. Ma'am, Vishal was first. So Vishal has given the answer first, but I am unable to see Vishal's answer. Beta, I am unable to see Vishal's answer. Seriously, I am unable to see Vishal's answer. Okay, now I got the answer. Gamer. Yes. Okay, now I can see Vishal's answer. Vishal has given the answer first. After that, Keshav has given the answer. Super. So now what we have done here, a simple logic I have applied. That is not logic or rocket science is not there. So one simple concept was there. See, I am having some energy stored inside me. That energy is nothing but the potential energy. So if I am going stairs by stairs, I am going up. So that means 100% the energy which is stored will be the potential one. It's not because of motion, it's because of the potential what is exactly we are using to go up the stairs. So here work done will be potential. So here potential is mgh. So just mass into acceleration due to gravity into height. So just we have written that one and we got the energy work done. And once we have got the work done by time, that's it. So simple concept is there. So now we are going to go for the next question. What should be the power of an engine? What should be the power of the engine? What should be the power of the engine required to lift 90 metric tons? Okay, 90 metric ton, 1 metric ton is equal to 1000 kg. Okay, so 90 metric tons, okay, of coal per hour, 90 metric ton of coal per hour, 90 metric ton of coal per hour from a mine. From where? From a mine, okay, whose depth is 200 meter. Take G as, hi Shika, how are you beta? Take G as 10 meter per second square. Okay, so now what should be the power of the engine which is exactly taking 90 metric ton? So you have to understand that 1 metric ton equal to 1000 kg. So 90 metric ton will be equal to 90123 kg. So this is the total mass. So this is nothing but the mass. Okay, and the depth is exactly given to you. Depth is given as, means depth is given, h is given to you as 200 meter. Okay, G is given to you as 10 meter per second square. So what is the potential energy here? What is the potential with which the coal is exactly lifted? The potential is mgh. So now mass is 1000 into 10 into 200. So it is exactly going to come as 9 to the 18, 1, 2, 3, 4, 5, 6, 7. So 18 into 10 to the power 7 joule. So this is exactly the power, but they are telling that we know that time is 1 hour. So first work is we have to convert 1 hour in second. So time given is 1 hour. Time given is 1 hour. I told you have to be very specific about the units. So 1 hour means 60 into 60 seconds. Okay, so now power means we have to find the power. So work done, power is equal to work done by time. So work done here is 18 and then 1, 2, 3, 4, 5, 6, 7 by 1, 2, 3, 4, 5, 6, 7 by 60 into 60. So first work is 0, 0, 0, 0 cancel. Now 6 3s are 18, then 3 1s are 3, 3 2s are 6. So it is exactly going to come as 5, 1, 2, 3, 4. So power is this much watt. So that is power is exactly equal to 5. After 5, 50,000 watt. Okay, or power will be equal to 50 kilowatt. Easy. Power will be equal to 50 kilowatt. Yes, you can convert it into Shika. It will be 50,000 watt or 50 kilowatt. 50,000 watt or 50 kilowatt. Okay. Yes, 50,000 watt or 50 kilowatt. What will be the power there? The power will be 50,000 watt or 50 kilowatt. So we are going to go for the next numerical, because I told you full 1 hour we are going to do numericals. So we will finish this chapter today, so that from tomorrow I am going to start structure of atoms. Okay. Now next question, get ready everyone. A radio set A radio set is there. A radio set of 60 watt. So how much watt it is given? A radio set of 60 watt runs for 50 hours. Super. Runs for how much hours? 50 hours. Okay, runs for 50 hours. How many unit? How many units? How many units in kilowatt hour of electrical energy are consumed? Of electrical energy are consumed. Electrical energy are consumed. Come on, go for it. Go for this question. It's an easy question. You can easily go for this question. Okay. So a radio set of 60 watt runs for 50 hours. Okay. So power is given, time is given. How many units of electrical energy are consumed? So here you have to find the work done. So electrical energy consumed. I told you one formula, and that formula today itself I gave you the formula, and that is power is equal to electrical energy consumed. Electrical energy consumed by time taken. Okay, electrical energy consumed by time taken. So here electrical energy consumed, you know that the unit is kilowatt hour. Kilowatt hour. So I told you the commercial unit is kilowatt hour. So no need to convert it into some very big, no rocket science apply please. So just make it simple and solve. 3 kilowatt hour. That was absolute, very fast. Super Keshav. So I think you are taking so good interest in solving this question. What is there given? So runs for 50 hour. How many unit in kilowatt hour? So power is exactly equal to electrical energy consumed by time. So power is written as what? 60 power is already given. Electrical energy consumed by, we have to multiply 50. So just let it go with 3000 watt. 3000 joule equal to electrical energy consumed is watt hour na, sorry, watt hour. So I just wrote another unit for kilowatts. So electrical energy consumed is this much watt hour, but we have to convert it into kilowatt hour, because I told you na energy consumed will be kilowatt hour. So you know that 1 kilowatt hour is 1000 1 watt hour is 1000 watt hour is 1 kilowatt hour. So here we are going to directly write 3 into kilowatt hour equal to electrical energy consumed. Electrical energy consumed. Sometimes I am going blank. So now easy, because we know that 1 kilowatt hour is 1000 watt hour. So from here I have taken this 1 through 3 zeros. Very good, very good. Shikha, Keshav, back to back you are solving questions very nicely. Very good, nice competition, giving each other, super. Yeah. So shall we go for the next question please? So now next question, in an engine develop an engine develop 10 kilowatt of power. 10 kilowatt of power. So engine is developing 10 kilowatt of power. How much time? How much time will it take? How much time will it take to lift a mass of 200 kg to a height of 40 meter. G you have to take as 10 meter per second square. Come on, you can do it. G is exactly coming as 10 meter per second square. Come on, you can do it. Solve it fast. You can do it 100%. Come on, go for it. Come on, come on, come on, you can solve it. Where are the rest of the children? Shruti, Sharmila, not even a single answer is coming from all of you. At the time of offline revision, I am not going to listen all this. I am going to check your notes. I am telling you all. So be very specific. Start solving means start solving. Okay, Vishal, that was very quick. Vishal, Ashwin, both are telling 6 seconds. Huh? Vishal, Ashwin has... Kanishka is also telling 6 seconds. Vishal has changed the answer. Keshav and Shikha has changed the answer. Exactly, they are telling about 8 seconds. Let's check this one out. So what is exactly given for you? So power is given as, here power is given as 10 kilowatt. Fine. So power given here is 10 kilowatt. Now how much time will it take to lift a mass of, so mass given is 200 kg. Fine. Height is given as 40 meter and G is coming as 10 meter per second square. So again potential energy, mgh, potential energy stored in the body. So this into 10 into 40 will be exactly going to come as 2 4s are 8, 1 2 3 4, 1 2 3 4, and this much joule is there. So now we know that power is written in, okay, power is written in kilowatt. So we can convert this kilowatt into 1 2 3. Now it is coming as what? So power is coming this much. So power equal to work done by time. So time will be equal to work done by power. So work done is 1 2 3 4 zeros and power is 1 2 3 4 zeros. This gone second. So answer will be 8 seconds. The correct answer is coming as, maybe there will be slight Shrutika. Today it is delayed, Shruti. I am very angry. The person who is solving numericals so good, that person is silent today. Very disappointed. Seriously, Shruti, you have to perform. Only one thing is there, and that is now final examination is coming. I am not going to listen here and there. I want a complete sort of preparation from you. School side, what examination they are taking, but my level of conducting test will be bit high. So you have to get ready, because I didn't taught only NCERT. I taught the entire content, and now I'm going to ask questions from there. Okay, so it's time to test your knowledge. How much you have learned, how much you have stored in your brain, that knowledge I want to check. So ready everyone, how much time does it take to perform? Listen this question and I want everyone to answer. This is a very easy question. How much time it take to perform 500 joule of work, 500 joule of work at a rate of 10 watt. Come on, you can do it. At a rate of 10 watt. At a rate of 10 watt. Everything is written in this question. I want to check who is going to solve this question first. I really want to see the capability right now. What is the answer here? This is the most easiest question. Nothing is written here. Nothing is there in the question. Work is given. Everything is given. So what is the answer here? Shrutika, well done. Super. So Shruti, check everything nicely. Check the unit first. Okay. Shikha, Vishal, Shruti, typing error is coming. Yes, now you have. Kanishka and Shruti, now it is correct. Nothing is there in the question. It's a clear-cut question, yeah. It's an open and shut question. Work is given. Work is given how much? Work is given as 500 joule. And exactly power is given as 10 watt. So now what we are going to do here? Power is equal to work done by time. So here here work done is given as 500 by 10 and power will be exactly equal to what? Power will be equal to, cancel this. It is coming as How much time? So it is exactly power is given na. So sorry, this is given 500. So time means we are going to shift power. Power is exactly 10. So it is coming as 50 seconds. That's it. It is going to come as 50 seconds. Next question. Next question. Now, water fall on the blades of turbine. This question answer nicely. Water falls on the blade of turbine. I am going to announce one very important information. There will be one numerical test for both the chapters. Find gravitation numerical test and this chapter numerical test separately. So water falls on the blades of turbine, from a height of 50 meter, from a height of 50 meter, 100 kg water pours on the blade in 1 second. 100 kg water pours on the blade in 100 kg water pours on the blade in 1 second. Wow. Assuming whole energy to be transferred, assuming whole energy to be transferred, what is the power developed? What is the power developed to the turbine? Here you have to take G as 10 meter per second square. For your convenience, I have given you G as 10 meter per second square. Now come on, go for it. Hey, super. Shikha, that was very quick. Okay, now I will make the density related to object question ready. Now understood na beta what type of question your ma'am is going to ask. So density related to object numericals will be ready for you. Don't worry about that. I'll ask the questions related to density only. Not to fluid, only to density. Okay. So now just give the answer for this. That was very quick, Shikha. That was very awesome. Unit you check, Shikha. Unit you check. Only I am having problem with unit. Only I am having problem with unit, beta. Only I am having problem with unit. Come on, check the unit out. Yes, Shruti, now it is correct. No problem. You will become strong. I'll make you strong. Very, very strong. Huh? So now first thing is that water falls on the blade of turbine from a height of this. So H is given to you as 50 meter. Huh? So, and now mass is given as 100 kg. Okay. And now assuming whole energy and G is given as 10 meter per second square. So now what will be the power? Power will be mgh by time. So mass is exactly how much? It is given as 100 into 10 into 50, but it is given as 1 second. So it is going to be 50, 1, 2, 3. Chi. What level question they have asked? See. So it is going to come as 50 kilowatt. 50 kilowatt. 50 kilowatt we can say. Yeah, here nothing is written there. The question was very easy, Kanishka. Here, see, the easy trick here is, you see, whenever they will be giving kinetic energy, they will give you velocity. Okay, so their work done will be exactly based on kinetic energy. But here they have given you height, they have given you G value, and they have given you mass. So that means the energy will be stored in the form of potential energy. Okay, so the energy possessed by a body due to its position, and that only lifting, flowing, that part it will be written. And because of that, what you have to do, you have to find mgh. So here their work done will be totally mgh beta. Their work done will be totally basically MGH. I hope you might have understood. So I'm going to keep it till here. All the best for your test. So I think I should take your test in evening. Get ready, prepare polynomial chapter nicely. Evening I am going to conduct a test. Fine. I'll send the question in community post also, or in Instagram, Shika, so that you can also appear for the test. Fine. Bye everyone.